All right, welcome to the pre-Christmas meeting of Open Source Antibiotics Series 2. Let me share the screen, which has the issue on it that I just posted. Thanks for coming along, everybody. I guess the thing that we want to talk about mostly would be the new potency results, which came in from Paul Stapleton's lab, which I'm showing here. So here are the two controls. You can get it all on screen, that's good. Here are the two controls, 821 and 820, and which is fine. They gave, the same. Were these retested, or are those old data? Okay, retested, great. So there's continuity, that's good. And here are the results. I haven't had time to assimilate this, but there were some things here which were kind of interesting. I mean, for me, the big thing, I think, was that we varied the position of the nitrogen on this ring, switching it around a little bit, including a ring with the 2-pyridyl and another nitrogen, but switching it around, and lose potency when we do that. So these two results here lose potency when we do that, versus the kind of compound that's active that we expect to be active. So that's very sensitive. But this is an interesting one, obviously, that we maintain it with another nitrogen and we still lose it. So fairly sensitive, that. That doesn't mean that, I mean, it's not sufficient, obviously, for activity, but it's necessary. Doesn't mean that other heterocycles, I guess, with a coordinating atom there wouldn't be a good idea, but there is obviously significant sensitivity there. That's number one. Number two for me that stood out in terms of importance was this guy, which has the alternative ring system that we've been talking about, and which has activity, which is interesting. Unless I'm missing something, that's quite useful. A third minor thing is just the sensitivity of the substitution to being para. So, the previous compound with the methyl in the para position, not shown here, but was potent. And as you move that methyl round, you lose the potency. So for me, those are some of those things. I don't know, Ed, I think you already posted some comments about these results. And if anyone else has got anything to say, please say. Oh, yeah.
I think the cyano is interesting because that's quite a polar substituent, whereas all the others have been sort of methyls and chloros.
That's true. Yeah.
So the reason I wanted to make the parachloro and then the dichloro was I was looking at this topless analysis where you do a batch-wise analysis. So I think we've made all the first tier that they recommend. So then what you do is sort of put them in order of potency and go from there. And I haven't had a chance to do that analysis, but I will, and then I can post it. And it does give you some suggestions of what to make next, which would be, awesome. would be yeah. I mean, it'll be more substituted phenols at that position, basically, but maybe worth a shot because they are easy to make, usually.
Yeah, I've taught topless and I've never done it. So if you can do that, that would be amazing.
Cool.
Anything else that strikes here?
I think I mentioned this briefly to you, Matt, but just to get everybody else's sort of opinion on it, because it does kind of seem like we're hitting a wall around like 2 and 4 micrograms per mil in terms of potency. And
which is low. Micromolar is low, right?
Yeah, it's not actually that active if you convert it to micromolar. So I don't really know how to break through, but I think it would be good if we could figure that out. And I'm just not sure.
I'm wondering if it would make sense to replace the nitrile with an amine.
I mean, aniline or
yes.
CH2.
Yes. Sorry, an aniline. Yes.
Yeah.
Just thinking about it in terms of whether that extra basicity might help break through in terms of potency.
Okay. Yep, we don't have anything, right, with that, I don't think.
No.
I'd assume that the para-dimethyl aniline boronic acid is probably pretty cheap.
Mm.
Also, another point of concern is that chloro on that core is probably not going to be that stable, right?
Which one?
The 978. So I was wondering, can we fluorinate, maybe even cyano on that position?
So I'm working on making the methox, but I just didn't get it clean enough to get tested. So that's something else.
Yeah. It might be possible, even if you have enough of that 978, to do a Finkelstein reaction and put a fluorine on there.
Yeah, I mean, the comment about trying to break through potency is relevant here in the sense that, each time we make something, of course, it takes time and effort. And so I wonder if the changes that we are looking for, besides being methodical about it with things like a topless analysis, should be slightly bolder changes. I mean, an NH2 there would be a big change in place of the cyanin. Yeah. Chlorofluoro maybe if it's easy, but that's not a substantial change, I suppose. What you're talking about, Dana, is improvement of 2 or order of magnitude better, right? That's what you wanted to see with some of this, and yeah, we are kind of flat here still, and we can't pour infinite resources into it.
978, it shows that chloro you can substitute at that position. I don't think it. I suspect it's not giving you an advantage, but it does suggest that maybe you could put more sort of exploratory functionality at that position.
On the 978, I was wondering, what would happen if you popped an amino in that position?
What? Hang on a second. Let me just go back to.
Yeah, so one of the reasons I was interested in the chloro was because I was thinking we could potentially do some substitution there if the other substitutions that we've tried are tolerated, which it looks like they are. So yeah, I think that it would be worth making maybe 1 or 2 where we tried that.
In place of the chloro, did you say?
Yeah.
In place of the ring chloro, in place of the core chloro, or the topmost ring chloro?
No, on the core.
Oh, on the core, yeah. Amino would be interesting to try on the core.
Yeah, and chemistry wise, how is that looking at? Is that something we can simply access?
I think so. I think it would be kind of interesting to see if we can just do the chemistry on that compound.
Oh, yeah.
But otherwise, we would have to go back to the beginning, maybe.
I was just thinking about the cores that you sent, Laurie, which I was going to come to. There's one here with the methoxy there. Yeah. Obviously.
Because there are also some in the D&DI set which were active with the methoxy, which is why I thought that we should make that.
Forgive me for not remembering. So I noticed that there was some obviously pyridine is the 2-pyridol is the one that's there the most often. Then you've got there was the pyrimidine. Have you done any substituted pyrazoles or imidazoles?
In place of the pyridine?
Yes.
I don't believe so.
I think they were on the ideas, things to do. But yeah, I think some of those would be interesting.
The precursors for them are ferociously expensive.
For what? Sorry?
Yeah, we need to try the 1-pot method, I think.
Yeah.
Yeah. So we're about to start looking at so I think it's 866. I'm really glad my video is currently off because you would have all had a lovely view of my forehead. So I think with 866, we're about to try something similar to that, but actually like putting the tetrahydropyran in place of the methyl, which is not foreign to Dana.
866, this guy.
Yeah, so we're thinking about something like that. I think we won't have the methoxy at that position around the core, and we'll have the 4-fluoroaniline as our.
I'm a bit skeptical of those 5-membered rings in that position. I mean, so none of these are exact match pairs to anything else that we have, but
Yeah.
they're similar, and you can see any 5-membered ring is inactive that you try to put down there. So
You don't have any activity with any of them?
Basically, if you
those
change
are all
it to
greater than
pure dial,
32.
If
Yeah.
you change it to pure dial, the thing tanks.
So it's 7 for 7 on those 5-membered rings. Yeah, are all inactive.
Yeah, then there's probably no point.
But of course,
Suggest.
with the amino side chain, right?
Mhm.
All of
Yeah.
them.
And sorry if I interrupt. Trying something with like something bigger. Maybe 5-member ring is low is too small, and 6 is fine, but 7 maybe.
All right. Yeah, tricky to keep aromaticity.
I was hoping you could try a substituted 2-pyridol, but I don't know how synthetically accessible that would be.
They're
But
fine.
I think,
Well-
put a naphthol there, if I'm not mistaken.
We could try quinoxalin or quinoline in that position. The boronic acids for that should be available.
I'm sorry, I think I meant quinoline that we've tried. Ed, do you remember? Is that the one that you made?
But that was in the top left, not in place of the pyridine.
Okay, just kidding then.
All right.
Could you actually put, so where that chlorine is on, was it 978 in the data that you just got back? Could you actually put like a pyrrolidine or something there?
I was thinking, yeah, if you do azitidine, but that's going to be the 978. If you put an azitidine in there, you know, a small nitrogen heterocycle, that would be really interesting.
Yes, that's kind of what I was thinking about. But whether you
Azitidine, I'm probably not saying it right.
Yeah, but what is the advantage of the azitidine over the pyrrolidine? I mean, the pyrrolidine would be cheaper to do, if nothing else.
Well, smaller.
Yeah, I feel like the pyrrolidine would be a good first step. Though, if it's tolerated, then yeah, sure, you would look at modifying the ring size. You could switch it out for like morpholine, piperazine, homopiperazine.
We don't know.
You could
We
do a
don't.
lot, but-
It's true that we don't know if we can put another cycle on that, and then it would be this sort of tetracyclic thing, which would be interesting. But
I mean, I'm thinking it would need to be saturated.
yeah, it would be it would have to be a small saturated nitrogen heterocycle, or nitrogen. Yeah, I don't know. Morpholine in that position. I don't know.
So we
Could
haven't tested that, have we?
Could that be done through palladium catalyzed, like Buchwald Hartwig, on that core, or is that too bulky and the whole thing would not work? Or do we have to start from? Could we start from 978, or would we have to go back a couple steps?
No, but
Yeah, I haven't looked into that, but we can try it.
But you'd want the nitrogen in the equivalent 2 position, no? Isn't that
Yeah,
what
but
you're
we're just
mentioning? So
saying
there's a coordinating atom here, but you've got a smaller ring. Is that what people are talking about?
No, we're talking about 978, popping nitrogen-containing substituents on that chlorine.
Oh, here.
Yeah.
Oh, sorry. I thought we were talking about replacing this with a saturated.
No.
I mean that yeah, I jumped. That was my bad.
That's actually brilliant.
I think it would be worth spending a bit of time trying to think about what advanced intermediate you could make that had that chlorine with a handle on it that you could use for synthesis of a variety of things.
Yeah.
I mean, I don't know whether, going to bring the iodo compound through or something like this that gives you the ability to try a whole range of things, chemistries.
Well, you could try always Finkelstein popping off the chlorine for an iodine, but it depends a lot on the core itself.
Well, we'll just have to look through the literature and see what would be the best way.
Yeah. I mean, that core is used in a bunch of other drugs.
If we did try and do sorry, I got distracted by thinking about a saturated heterocycle in place of the pyridine. If we did do something like that, how would we make something of that kind if it was like a pyridine or something of that kind in this position? I don't know if that's even worth it, but that would
You mean links via the nitrogen or linked via carbon?
linked by carbon, so it's hard.
Have you tried saturated rings with the one pot procedure, Lori?
No, I mean,
Okay.
we haven't tried anything not aromatic there.
Yeah.
Oh, actually, hold that thought. Maybe.
Do we know though if that N linker on the top that's going to be given by the one pot procedure affects potency in any way? I know Ed tried making the standard core with the toluidine substituent, but because we could be losing potency on the one pots just from that N linker that's formed on top from the isonitrile.
It is tolerated. We've got some with some good activity, I think.
Oh, the N linker is. Oh, it is. Oh, okay. Then I'm sorry, I just went down the wrong path.
So what here for 851?
Yeah.
I mean, as well, if the para versus ortho trend that you saw with the methyl follows, then the 4-fluoroaniline should be more active. I don't know. That's pure speculation. We have actually put a methylene linker between the pyridine and the core. I am just looking at how we're trying to find how we did that.
Between the two rings?
Yep. We tried pushing it out a bit to see if that would have any effect.
Between the two bottom rings. Interesting. And maybe we could put a toluene substituent on top. Yeah. That would require toluene isocyanide, which have to be made in situ.
Yeah, if there's some nice chemistry there that you know about already, that would be useful. Or if there's something we can do just to fill that little hole, that would be nice.
Yeah, I was gonna try and order some starting materials to start doing the one pots when we get back, because I think it'll give us access to some interesting compounds.
Yeah. Okay.
Are you gonna use the para-toluene for the top substituent then? Make para-toluene isonitrile?
I think at Northeastern they've been making the isocyanides sometimes, right?
Yeah, we can either make them or if they're commercially available, buy them. One of the things that, oh no, it's fled my mind. Never mind. I'm sure it will come back. I hope it will. Sorry.
Yeah, I mean, sorry, carry on, Laurie.
No, I've just completely forgotten what I was going to say.
Okay.
Sorry.
So for Daniel, if you were able to just post on that synthetic approach again, and then talk about some of the materials that are available that might take us into different places that we want to go, that would get everyone's minds thinking about what we might want to make.
Yeah, I think Lori's already sent me the procedures, but I can't remember if I put them on GitHub or not. So if I haven't, I'll just do that.
Okay, because I mean, if we see what the ingredients are, we might start thinking about things that we could just buy to mix in there.
Yeah.
That'd be pretty handy. And if there's something particularly well suited for the 978 precursor Chris was talking about,
Mhm.
that might prioritize one rather than the other.
Well, I can't find the one with the paratoluene isocyanide, but sigma stocks the methoxyphenyl.
Right. Okay.
I think that was what I was going to say. The next batch of compounds that we just sent you, where we've got the N-alkyl derivatives, I think that could actually be quite interesting in terms of whether you maintain any kind of activity. I guess I'm wondering if the NH is maybe bad, and by blocking that, it kind of is a little bit more similar to the core and the scaffold that you've been using.
I'm sorry, which compound, sorry?
Like with 6729, just the fact that we've got those different alkyl groups, I'm kind of curious to see if that brings it sort of a little more back in line with what you've been testing, because you don't have that free NH like we've sent with most of the compounds that we've sent to you so far.
I see. Okay.
Yeah.
Yeah, that's true. Right. Good. Yeah, that's nice. There's a bunch there. Okay.
If they do come back, I wonder we could theoretically have a linker between the two. Pyridine. Get some really weird stuff.
Yeah, if it's chelating, yeah.
Yeah, so I'm just looking through the procedures. We still just made an aldehyde. So we actually built in the methylene linker between the core and the pyridine, but I mean, we actually used a pyrazole. And so we have a methylene there, but we did it still via the same one pot that we've used before. So probably not super helpful.
Wait, so that's accessible with the one pot method?
Yeah. Inserting a methylene, but it's probably not going to get you to your to a saturated derivative.
Right. Okay. I see. Yeah. So okay. Yeah. Right.
Yeah.
So I mean, in the synthetic planning, Dana, if you can think of a way of somehow involving a saturated ring in place of the pyridine, that would be interesting. But if it's too hard, then we can forget it.
Would you be able to quaternize that pyridine and then reduce it, say with methyl iodide, selectively?
Selectively. Yeah, I'm just looking at all the nitrogens. I don't know.
Yeah, wouldn't the imidase of pyridine go first?
I don't know.
Maybe.
You'd have to nuke it with a CH3I and see what you get out at the end, right?
Although you're right. I mean, it is the middle ring is much more hindered, I suppose. But it's an interesting one.
It's well shielded by the two other rings.
Oh wait, sorry, you're talking about doing it on this scaffold. That's my bad.
On something like
okay. Yeah.
On well,
875 kind of thing. Is that what you mean?
Yeah.
Yeah. Yes. And then if you can quaternize the pyridine, can you do not a hydrogenation but a reducing agent to reduce the pyridine down?
Yeah. Yeah. So many nice things. I mean, I think the earlier comment you made, Chris, about trying to get an advanced intermediate, which allows the attachment of a bunch of different things, is a really good one. If we're trying to be bold about the changes, making a ring saturated is a bold change, but it can be difficult to do unless you happen to get lucky with a procedure like the one you just mentioned. I mean, it's always worth a shot, particularly if we have plenty of one of those compounds. I think, Ed, have you just made a big batch of 821?
Yeah, so I did a gram scale reaction of that and got about 560 mgs.
Right.
So I think this reaction is pretty much 50% every time. So I think in total I've got about 800 now.
Nice.
I was speaking of hydrogenation. Do you think it would be possible if we could to hydrogenate those two methylenes at the edge of the core on 978 again? Well, obviously take off the chlorine, but hydrogenate the two in the 6-membered ring.
What, here?
Yeah.
Well, proof's in the
That
pudding.
core's been made.
Oh, the hydrogenated one in that position?
Yeah. And it's, I think Alvaro made it.
But did it have that problematic top benzylene dioxazole?
No.
Yeah, it had that substituent, remember, that killed the potency? The benzodioxazole?
Yeah.
So could we see if we can make 818 but with a paratoluol? Because the benzodioxazole killed the potency, remember, with that SB compound?
I mean, you'd have some pretty hefty metabolism issues, I would suggest.
Yeah. Yeah, I think because we were already concerned about the metabolism on the 5-membered saturated core. So I think that's why we didn't pursue the 6-membered any further. So, maybe.
Yeah. I just worry that you're increasing lipophilicity as well.
It seems like this compound refuses any sort of polar groups you put it in other than a cyano.
Okay, we can draw up some plans. Yeah, so if you're happy to think about some potential starting materials, Dana, we can pursue that discussion, thinking about advanced intermediates of this kind, and maybe playing around with a little bit of chemistry if Ed can sacrifice some of his 821, for example, trying to reduce this ring, perhaps. Not a terrible idea.
Methyl iodine, that's real old school. I like it.
But
maybe even.
I mean, I think the 5-membered ring aromatic nitrogen-containing ring in place of the pyridol seems risky based on what we know, and maybe it's better to play with this.
Sorry, have you tried moving the pyridol nitrogen to the 3? Move it across one. So kind of like it is in 874, but ditch the second one. I mean, I'm thinking.
We've tried the 2, 3, and 4 pyridol. Yes.
And?
Only the 2 is active. Yeah.
Okay, so could you just go back down to the 5-membered heterocycles? Sorry.
There it is. But it's again with the right. This guy with the 3 is that right? Yeah. Yeah. So it falls off. Sorry, is that too small?
Okay, and so so you've still got. I guess when I'm looking at these, so to go back to Matt's point before of having the nitrogen in the same position as the 2 pyridol, yes, but then you've also got additional nitrogens which were unfavorable.
That's true. Yeah.
Is 843 an oxazole or a thiazole?
Thio, I think.
Okay.
Yeah, thiazole. Yeah.
Oh, interesting. Okay.
So I mean, just so pyrrole is obviously an NH, right? So you'd need so you need an oxazole or something, but that's very similar to the compound we've got already.
Isoxazole?
So I mean, if you want a nitrogen which is coordinating, so an NH acceptor, not donor. So you need something like an oxazole rather than a pyrrole.
Yeah, but I guess I was thinking if you had the thiazole would be better because sulfur is more like carbon.
Yeah, it should be more. You would imagine that would be a bit more like a pyridine. Yeah.
Yeah. So I mean, I think you've tried what I would have gone with next.
And sorry, the rest of the core we'd expect to be active. Do we? Just because of what we know. So hang on a second. Sorry, I know. Other people scrolling is really irritating. But that's meta-fluoroaniline at this position.
We haven't got that.
So this is
But the 2 is
orthofluoroaniline.
Yeah.
Has a sniff of activity.
Mm-hmm.
Not great, but it's something. So if it was going to be better, you'd expect it to be better than that.
Yeah.
Let's say, roughly. Not.
Yep.
You can't definitely conclude because we haven't got the right compounds, but you'd think it would show something.
Mm.
One thing that does occur to me and is that could we replace the central part with a benzimidazole? So you're moving the nitrogen at the bridgehead to the next thing over. Because that might make your chemistry a lot easier.
I'm sorry, which way? Sorry,
So,
I can't quite see it.
So if you take, well, an example here would be if you take the first one, 840,
Yeah.
But it would forget about your substituent at the top left for the moment. Move that nitrogen one position over to the left.
Yep.
You'd have to move the double bonds around, but you would end up with a 2-aryl benzimidazole.
Oh, fine. Sorry. Yeah. Okay.
And then you could put substituents on by just alkylating the nitrogen.
That's true. Mm-hmm. Right. So.
I don't know if that would just make the chemistry easier, if they're active, that is.
So we don't have anything like that, do we?
No.
Mm-hmm. All right. That would make it easier, I would assume.
I feel like there's a lot of chemistry around the pyrazolopyridine, even.
Okay.
I've only had one coffee this morning, so I just moving that same nitrogen, but down so that it's next to the other way.
So you have
To
the nitrogen side by side.
Yeah. Back
Moving
one
side
where
by
you just
side?
were. Yeah, side by side. I feel like that also could be relatively amenable to diversification. I don't know if it would make it any easier versus what you're doing currently.
Yeah, I mean, so I guess, yeah, I mean, Chris is talking about just alkylating a bunch of benzyl compounds, right?
Yeah.
Which would be very sweet. And adding in substituents at the middle carbon is meant to be easy, but one of my other students would maybe disagree with that assessment because she's been trying to do that for one of the open source malaria projects, and it's not straightforward.
Okay.
But I think if you can buy, sort of, benzimidazole and then try and brominate and then Suzuki it, there are possibilities there.
Mm.
So yeah, that's an interesting idea.
Yeah, but I think the idea of perhaps looking at these cores, and particularly with the idea of synthetic accessibility in mind, might be worthwhile, a bit of literature work.
Yep. Holiday reading, it's called.
You may say that.
Okay, look, that's very useful. I've made some notes here, and if I forget something, people can chime in when I post them. But that's lots of things to think about. And yeah, I mean, it is good to think about significant changes rather than single atom changes. I mean, in terms of single atom changes, maybe in a core, but not on the periphery, is where we need to be going. Because I think you're right, Dana. I think we've got to try and hit something better than this. if we're going to get anywhere with these compounds.
Oh, so we can buy 2-pyridyl benzimidazole from Fluorochem. It's 17 pounds for a gram.
That's not bad. And then alkylate away.
Hmm.
No, that's nice. Great. Okay. So post that.
Christmas gamer.
We can start that conversation.
Yeah, I'm looking at the other cores as well on SciFinder to see what we can get.
Great. Great. Good stuff. Okay. All right. That's been very useful. Thanks for all of that. That's really good. All right. No, I mean, I think that's pretty much the main thing that I wanted to talk about is were those data and what we could take away from them. So that's been extremely useful. Cytotoxicity is still underway, Dana, right? Ed, you haven't heard anything back? Okay, which has taken a while, but I think some of our internal searching tasks in the School of Pharmacy have maybe taken priority recently. Ed, do you have any synthetic chemistry update? I mean, you've been wrapping things up, right? Because the lab's closing down.
No, the last thing was the benzofuran scale up.
Yeah, great. Okay, which is ready for HIFA if they need it. That was one of the reasons we were doing it, but it could also be useful for some, late stage functionalization. Okay, great. And then on this page, there are a bunch of other things which are just assigned to people, but which are not chemical necessarily. I mean, they're not synthetic. So just some things to do with documentation and fixing up, the various things. So I've assigned everyone to those things down here. This is a new issue. So sorry, everyone's got a little bit of pleasure there. And it's on me. I'm going to try and just draft up another newsletter before Christmas, because it's always nice to have pre-Christmas things to sort of summarize where we're up to, and I'll try and do that next week, just for fun. The one thing I was going to say is just to thank you, Laurie, for the shipment of the compounds, which are in our fridge, which is looking really good. So that's really great.
Most welcome.
Just to acknowledge that contribution as being very valuable. So thank you for that. Also received is the starting material for the compound that we're talking about in the Mer ligase project. So that's also really great. Thank you. And I mean, we'll get these tested, with any other compounds in January, first thing.
Yep.
Okie doke. I mean, of all those things, was there anything anyone wanted to talk about? We had made really quite nice progress last time on the terms for the molecule donations, and so one of the things here for you, Dana, was just to make sure that those are put on somewhere central, right in the molecule donations page. I think they're looking really good. If we're all happy to sort of go ahead with those, is that all right? Okay, because I mean, I think it's a really nice thing that we're doing, and actually these issues are coming up in other projects, in fact, and I'm kind of directing people to these terms because people are thinking about the same questions, which is quite interesting. So that will hopefully make things simpler, and then we can start going out to people and saying, well, how about it? All right, but I mean, other than that, I think that was everything that was important. If people can just keep an eye on some of these actions and try and clear them if they have some time between main course and dessert, Otherwise, that's it. I think that's everything that we wanted to talk about today, which has been very helpful. If there's nothing else,
everyone, we'll see you then. See you in the next year.
Yeah, see you sometime in the new year. And thanks for coming along and all your contributions.
Hopefully, I'll actually be on my way to being a pharmacy tech.
Really?
Yeah.
Okay. As well, you've got some final exams coming up or something?
No, just starting actually.
Oh, cool, great.
You only need a Regents diploma, which is a special type of high school diploma, which I have. So.
Okay. Great. All right. Thanks for coming along. Nice to see you. See you in the new year.
Just starting.
Thanks, everyone. Happy holidays.
Bye. Bye.
Bye.